Hello, everyone. Good morning, good afternoon, and good evening from wherever you're joining in the world. My name is Erica Hashemi, and I'm part of the Mojo Networks marketing team. On behalf of our presenter, Sean, and myself, I'd like to thank you personally for taking the time out of your busy schedule to join us for one of our very exciting weekly demos. I'd now like to introduce our presenter, Sean Blanton, Senior Product Marketing Manager at Mojo Networks. Today, Sean's going to use the next 30 minutes to discuss and demonstrate how Mojo can automate your Wi-Fi, as you also take away the 4 features that can seriously minimize the mundane tasks that you face every day. So without any further delay, I'm going to go ahead and pass the floor to Sean, and he's going to get started.
Thank you, Erica. And thank you, everybody, for joining and watching today, watching in the future. As Erica mentioned, my name is Sean. Really excited today to talk to you about how to automate your Wi-Fi. We often ask the question, how much could you accomplish if you didn't have to spend so much time with manual, mundane Wi-Fi responsibilities? It's a challenge out there, partly because teams are small and each individual IT administrator has a lot on their plate. But also, dedicated Wi-Fi experience is not something that is readily available. In fact, many organizations have that jack of all trades approach to their IT organization and can make for some very long, mundane responsibilities as it relates to Wi-Fi. So Mojo provides the only Wi-Fi platform that puts automation to the forefront. And we're implementing features that are tailor-built to reduce manual time and remove the mundane tasks that are typically associated with Wi-Fi management and Wi-Fi security. And so today, we're going to focus on 4 key features that directly address the time waste and error-prone tasks that are plague Wi-Fi administrators today. And in particular, we're going to focus on these 4 key topics: change, and we'll dive into Mojo Navigator; troubleshooting, where we'll take a look at Mojo Packets; wireless security, we'll look at Mojo Airtight; and finally, we'll talk about how to automate workflow using Mojo API. So let's start with change. Now, Mojo Navigator builds in automation. It keeps the platform persistently up to date without impacting the edge. I work with a customer that has a pretty large deployment, 12 campuses across the country, each with a handful of buildings. So we're talking about a couple hundred access points per campus. Now, when it comes to change, one of the things that is very difficult for them is firmware updates. Now, updating AP firmware is still one of the most error-prone and labor-intensive tasks for an IT administrator. It takes a lot of time. So much time, in fact, that the average deployment is 2 to 3 revisions behind current code base, if you look at Wi-Fi in the big picture. And it's often because the updating process is very manual and takes a lot of time. Updating individual instances, whether it be controllers or networks, the process to bring down the update, to then push it out to access points to make sure that you're minimizing downtime, it can be very, very intensive. In fact, I want to tell a little story about customers of ours that have really been impacted by how Mojo automates change. 2 years ago, there was a major vulnerability that affected really almost everything communicating over the internet. It was called Heartbleed, and it affected SSL communication. And how that affects Wi-Fi is that it impacted the integrity of AP console communication, whether you're talking controllers or cloud. This attack allowed for data to bleed through that communication. It was a big problem. There are still many systems out there that are susceptible to this vulnerability due to its time-intensive nature. So where we come in is we automate that change. We were able to update our entire cloud platform within 3 days, and we were able to help our customers get their APs up to date with the latest firmware and the fix to that vulnerability in record time. So let me show you how we do that. As I transition over to Wireless Manager, I want to call your attention to the left of the screen here. This is what we call Mojo Navigator. It is our hierarchical organizational tree. It allows me to organize my networks. In this case, we have a large school district in a logical manner. But more importantly, it allows me to create and automate change. If we take a look at our access points today, we can see that they're in need of an update. We have hundreds of access points deployed across these schools. But the beauty of this system is my ability to perform these bulk actions. I can select everything on the screen, focus in on those devices that require that update, and push it out immediately. It doesn't matter if these access points are distributed across multiple schools. This bulk action allows me to click once and distribute that change across my entire organization. And if we want to go a step further, we want to take that human effort out, we can come into our configuration and we can actually update the firmware process entirely on a location by location basis or across our entire platform. We can enable new device upgrades. Every single time we install a new access point, part of that installation process will involve an automatic pull down of the latest firmware. And then for ongoing updates, we can actually input our change control windows. If every Wednesday and every Saturday, we're allowed to start at midnight and have a 2-hour upgrade duration window, then the system will automatically check during these windows if a firmware is available. And if so, we'll distribute that change to any access point under this particular setting. This makes upgrading very, very simple. And as it relates to Mojo as a whole, Mojo Navigator gives us the power to perform these bulk actions and to automate that change, whether it's firmware updates or configuration updates or anything in between. So now let's talk about troubleshooting. Troubleshooting is another very time-intensive activity. I have a customer that is highly distributed. They have about 400 locations on the West Coast, up and down through California into Washington State. Their IT staff has never used Wireshark before. They've never felt that they needed to. And for them to look at packets to see intuitively that flow of conversation, to spot something out of place, is not a skill that their team has. So it's almost an impossible task for them to dive into and correct ongoing persistent issues that are out there on their network without this deeper level of expertise on the team itself. I'm reminded of a story that they told me about a support desk engineer, junior, starting out on the job, getting called by a very frustrated user. This particular user was based in one of their offices and was trying to stream music at their desk. This was allowed by their network policy, but the problem was the stream kept breaking over and over and over again. And this particular employee was pretty frustrated by this on and off again, no change in behavior. What we're able to do is give them packets. Mojo Packets is a graphical packet analyzer. It's hosted in the cloud, and it's designed to quickly analyze and visualize packet captures for those deeper Wi-Fi issues to give you guidance on where to focus your time. I'd actually like to show you that particular trace that I just talked about and give you a quick demo of how Mojo Packets works. So as I come back into my console and I flip over to Mojo Packets, you can see that I've actually had a couple of packet captures that I've uploaded over time. In this particular case, you'll see that Packets automatically analyzes the capture. It's not just about uploading this raw data, but it's taking the effort to actually look at the information within the packet capture and tell me what's going on. In this case, 5 devices were picked up in the trace. We know exactly which device we need to focus on. This one right here. And we know why. We know what to look for. Association failures, reassociation failures, EPOL and EAP failures. What this is telling me before I even look at the trace is that I have an opportunity to, and I should be looking for a device that is having problem connecting to an access point. And so we hop in and we take a look at that trace. And the visual nature of Packets lets me spot exactly where I should focus my efforts. Right away, my attention is caught to this area of the trace, where I see these reassociation errors happening. And I can look in and I can actually look at the very individual packet that is the issue at hand. In this particular case, this client was hopping from access point to access point. But with this new information, the support engineer was able to ask a very critical question. Are you moving? That question alone helps solve the problem because they weren't moving. They were stationary. Yet the access point was just exhibiting behavior that showed it bouncing from access point to access point. What this told them was that the client device was roaming aggressively, and it turned out that with an updated driver on that particular phone, the issue was solved. In this case, a relatively junior team was able to automate the analysis of that packet capture, which gave them the guidance they needed to solve the problem. Now, anytime a persistent issue occurs, they grab the capture, they perform some basic tests while the capture runs, they throw it into packets, and it helps them to resolve the issue quickly and automatically. So let's shift gears and let's talk about wireless security. Security is always a challenge. Security tends to be something that needs a lot of time and a lot of effort. Looking at policies, designing them very specifically. I work with a school district, 23 schools, K through 12, about 750 students per grade. Now, what's their problem as it relates to security? You might think it has to do with CIPA compliance, a fear of hackers or criminals trying to get on their network. Their security problem is that it's really difficult to control what students connect to. Every student has a smartphone, and it's so easy for them to bypass the network security controls that this particular school district has put in place to protect these students by connecting to their soft AP. The only solution that they could think of was to empower teachers to confiscate phones if they're being used, to keep an eye out and to try to see if students were doing it. As you can imagine, not a very effective security policy. So with Mojo Airtight, a system that collects and analyzes scan data automatically, minimizing the volume and the effect of false positives, with that information, we could actually implement a real security program that automatically kept students off of those soft APs. The administrator I was talking to was telling me that he can't force students to use the network that they've deployed. He would love them to. It's got content filtering and it's got IDS and IPS on the network. It's designed to keep the network secure and to make sure access is going exactly where these students need to go. But because of that smartphone, flipping them into AP mode, students can hop on it. They can play games. They can go to inappropriate sites, perhaps. They can do anything they want because they're beyond the control of the administrator. So what we were able to do was actually set a policy that defined students in such a way that allowed our prevention to come into action. So let's take a look at how that process works. I'm going to zero in on my office here in Los Angeles. And we can take a look at my security dashboard. Now, right away, I can see that I have some problems. A rogue access point is on the network, and 2 devices are connected to it. I have my single device scanning while providing access. So let's take a look at our security mode and understand a little bit better as to what's going on. Now, from a scan, my device is telling me that currently there are 29 active networks that surround my office. But what my device is also doing is it's creating traffic on the wire, marker packets, these small broadcast packets that float through the network, and should they encounter an access point, they get float into the air. It's through that simple process, that behavioral technique, that I can look at 29 active networks and quickly flush out the 27 that are off my network. I can focus on the 2 that are on my network. In this case, 1 that I deployed and 1 that I did not. And there's my rogue. So right here, I have a foolproof technique to help me identify access points on the network that should not be there. And by virtue of that, I can also determine what is off the network. So how did we help the school out with their issue with students connecting to soft APs? Well, we use that same principle to look at our Wi-Fi client. In this particular case, rather than relying on automatic classification, where certain devices might connect to our network and receive that authorized classification, instead, we just assumed that all devices were authorized. This was a remote campus, so we didn't have the issue of clients outside of the school potentially being caught by this classification technique. What that allowed us to do was implement what we call over-the-air prevention. This prevention is what gives me the chance to look at a client, an authorized client, connecting to an external network, and to block that connection. Through a combined technique of de-authentication packets combined with some over-the-wire techniques, we can keep those students off of those soft APs by virtue of the soft AP being external. And what this meant was that during school hours, students could only connect to one Wi-Fi network, the school network. User rates jumped, and he had more control than ever before as to where these students were going while on the network. So finally, I want to talk about automating workflow. Here, we really start to extend what automation means in the context of Wi-Fi. What we're talking about is leveraging an open architecture that exposes every function through our RESTful API. And what's really important is that our API allows both push and pull capabilities. So a customer working with, this time, a university, single main campus with about 24 remote campuses. What they needed was empowerment. In particular, certain groups of faculty, especially at these remote locations, running night classes, they needed the ability to create specialty networks. But the centralized IT group recognized that it was near impossible and not desirable to train them to use an enterprise console. The solution, at least until we were able to work with them, was to create a submission process. Faculty would submit the type of network they wanted, and they were given guidelines as to what that network should look like. And then there was somebody always on call to create and then dismantle these networks on the timetable of the teachers. Not a perfect solution and riddled with errors, causing lots of headache and lots of manual effort on the side of the central IT organization. So this university wanted to allow night school teachers the ability to create a network for student after hours. The IT administrators didn't want to be the ones responsible for doing it. So what did we do? We used our API to create a simple tool that would allow a non-technical staff to create a network. And using the API, we were able to automate the development and distribution and ultimately deployment of that network. That tool, by the way, is called Mojo Nano. And that's what I want to show you guys today. So let's start by actually looking at Nano. And as far as the interface is concerned, you can see here we work to simplify it. In fact, it's meant for smartphone use, which is why the screen is as it is. The steps to create a network are really simple. I create my new network here. I add my password, or perhaps I open it up, depending upon what my opportunity is. And then should I need it, we have some advanced controls that can be flipped on or off as needed. After I save my network and then deploy it, that faculty member's time is done. But what's happening in the background is that the API is automating every other step along the way. So let's take a look at what those steps are. As we come back into our network and we jump into our folder here, we can actually see that first, our new network has been created. This network using the API is built around best practices. So it actually turns on and turns off a variety of features relative to a network with best practices, whether it's a firewall addition, SSID scheduling, or ARC optimizations. Then it creates the template to apply to the access point in that particular school. You can see here that it's not only created the template, applied it to every possible radio that we have, just to be sure, but it also deploys it. It creates the template and then applies it to the device so that it automatically takes on those configurations. You can see here that it's applied our new network to our C120 deployed at this particular university under best practices. And that way, every single device takes on that change, and within 2 minutes, that faculty member has the new network, the IT administrator not on call, and doesn't need to put that extra time in to accomplish this task. We've opened up our API framework, and we allow our customers to not just dive deep into the guide to create and code their own applications and value-added services, but we also give the ability to create your own keys and to develop rules around those keys. Using role-based access control, you can be very specific about what that particular application can do and what it can't do. So thank you guys for spending time today learning about the 4 features that minimize the mundane tasks you face every day. Again, our goal is to answer the question, what more could you do if you didn't have to spend so much time on mundane Wi-Fi responsibilities? We want to automate change using Mojo Navigator, our hierarchical organizational structure that allows you to distribute changes, be it firmware, configuration, or policy changes across the board with a single click. For troubleshooting, we want to automate the analysis, give you a leg up in diving into those deeper Wi-Fi troubleshooting issues so that your time to resolution shrinks and the amount of time spent throughout the entire process is considerably less. When it comes to wireless security, we want to automate both the analysis of what devices are out there, but we also, and most importantly, want to automate the prevention. We want to automate the security of keeping clients off of the wrong network and on the right network. And finally, as it relates to workflow, our API framework allows you to automate just about anything. If you can think it up, our API can give you is the tool you need to create it. And with many customers and managed service providers alike, we've been able to develop some really great custom workflows that fit their needs and give them the features and functionalities they require to deploy successful Wi-Fi. And so with that, I'd love to open it up to questions about anything that we covered today.
Terrific. Thank you, Sean. I'm going to see if there are some questions coming in here. First question I see, can you filter clients based on their IP addresses instead of MAC address in the interface?
Yes. So within our interface, we have the ability to, and let me hop in here real quick to give you the visual. Through our monitoring tab, we can look at clients through a variety of different perspectives, be it through security or Wi-Fi. And in the case where our client's information is being passed up, we can actually filter top to where our devices are. We can look at and filter based off IP scheme. All of our columns are filterable and sortable, and you can create custom filters that will save so that you can flip them on and off again over time.